Hello, this is Ryan from DISTek. In this video, I'll be demonstrating the Dash automation feature. Here, you can see the Dash launcher in manual mode. From this mode, you can select configuration for manual testing. This, however, is not what I'm interested in showing you today, so I will click the script radio button. Here you can select a test script. Test scripts are Excel files with a specific format. I have already selected a test script called automationDemoScript.xlsx. When you select a test script, the fields below are populated from the test script. You can also override some of the default settings of the test if you want to. Now that everything looks good, I will click the OK button. As you can see, the test is now running. Notice in the background that the knobs and buttons are being turned and pressed automatically. Also notice that the control system that is connected to the dash is reading these outputs and commanding the LEDs to blink. The test can be canceled at any time by clicking the Stop Script button or by clicking the red X button in the upper right of the script window. We will take a look at the test results in a moment. For now, though, I would like to switch to manual mode and explain the controller application. I will click the manual radio button to do this. Notice that the controller configuration file field is still set to the configuration file that is referenced in the test script. I will now press the OK button to confirm manual mode. To give you a better understanding of the results of the test script, I will briefly go over the control system that we are testing. The purpose of this control system is to raise or lower a hydraulic system until the height sensor matches the commanded height. This system also has a manual raise and lower override input. The four controls on top are the inputs to our control system. The three LEDs on the bottom are the outputs. I have now moved to the test script. The test script is an Excel spreadsheet with one configuration tab and one tab for each test. In this test script, there are three tests: set point and sensor, raise override, and lower override. Currently, we are looking at the configuration tab of the test. In the dash configuration file field, you can specify the dash configuration file for the test. This field is required and is used to determine what inputs and outputs you can control or verify. The results path field specifies the folder that the test results will be written to. The stop on failure field determines if a test will continue to run if a test step fails. If a test name is entered in the run single test field, only that test will be run when the test script runs. At the time of this recording, the run single test feature is not fully implemented. The include timestamp in report file names field specifies whether or not to add the timestamp to the generated report files. Finally, the results file name field specifies the file name that the test results will be written to. I have now moved to the second tab of the test script. This tab contains a test called setPoint and Sensor. Testing in the dash works by setting and checking specified values at specified points in time. Each row where there is a % in column A is a comment. Comments have no effect on the test, and they allow you to write notes in the test. Each row where there is a number in column A has a list of commands for the dash to run. The number in column A is the change in time since the last row that was run. Using this test as an example, row 5 is run at 3 seconds, and row 8 is run at 6 seconds. Dash commands come in two types: set and test. Set commands send a value to the control system, while test commands verify a value from the control system. Once you set a pin to a value, that pin stays at that value until changed. Using this test as an example, row 3 has 4 commands. Each command begins with the keyword set, and therefore sends the specified values to the control system. Row 8 has 3 commands. Each command begins with the keyword test, and therefore reads the specified values from the control system and compares them to the value specified. If they don't satisfy the comparison, then that dash command fails. It is important to note that pins used in this test need to be in the dash configuration file specified in the configuration tab of the spreadsheet. Now that you understand how to read the test, I will explain what this test does. It sets all the inputs to 0 on row 3. It then verifies all the outputs are 0 on row 5. On row 7, it sets the commanded height higher than the height sensor. Then on row 8, it verifies that the control system is only activating the raising height pin. Row 10 sets the height sensor higher than the commanded height. Then row 11 verifies that the control system is only activating the lowering height pin. Now I will show what happens when there is an error in the test script. I'll begin by selecting a test script with errors in it, and then hit the refresh button to the right of the test script field. As you can see, there are some values in the test that are out of range for the given configuration. Let's look at the results folder. Here you can see CSV files and HTML files. These files both contain the same test results data, but in different formats. The CSV files are easy to parse with other programs, and can be used in continuous integration systems. Here we have opened a CSV file in Excel and are filtering on the test results. The HTML files are web pages that contain test results in a format that is easy to read and share with others. This concludes the Dash automation demo. Thank you for watching.